going to see energy bands in solids. This is very fundamental topic. You should know what are energy bands, how energy bands are formed. Okay, this will be useful to learn nanoelectronic devices. This is somewhat a higher level topic. Before getting into this, you should know what are energy bands in solids and how the solids are classified based on the energy levels. Okay. Okay, energy bands in solids. Energy bands in solids. An isolated atom brought together to form a solid. The electron wave function begin to overlap. Various interactions occur, and at a proper interaction spacing for a crystal, the force of attraction and repulsion find the balance. Due to the Pauli's exclusion principle, the discrete energy levels of individual atoms split into bands belonging to the pair instead of two individual atoms. In a solid, due to large number of atoms, the split energy levels for essentially continuous bands of energy. Okay, once again I repeat, an isolated atom are brought together to form a solid. What is solid? Generally, what are solids? Okay, solids are composed of group of atoms. Solids are crystalline solids, whatever may be. Solids are composed of group of atoms, isn't it? Okay. Now, what is an isolated atom? Isolated atom means single atom. There is no any atoms, influence of any other atoms is there. Okay, so isolated atom. If you consider any atom, the electrons are situated in the energy levels, right? 1s, 2s, 2p, etc. The electrons are situated in the energy levels. Okay. If you brought the group of atoms to form solid, if you brought the group of atoms, it forms solid. Okay. The electron wave function begin to overlap. If you consider this is one atom, okay, this is one atom, A atom. The energy levels of these atoms are here. Now this is another atom, B atom. The energy levels of atom is this one. Okay. Okay. This is 1s, this is 2s, and this is 2p. Like that, it is 1s, 2s, 2p. Okay. If these atom, the different distance between these two atoms. Okay, these two atoms are, if the distance between these two atoms are far apart. Okay, these are the influence of B atom on A is negligible, or the influence of A atom on B is negligible. See, that much far distance, which is R is very large. The energy levels of A and the energy levels of B are almost equal. Okay, if you brought these A and B together, bring close together, it will overlap. In small classes, in school days, we have heard about that if two orbitals overlap, if this is 1s of one atom, this is 1s of other atom, overlap, two kinds of levels form. One is bonding and another one is anti-bonding, right? So if two energy overlaps forms, or end up with the two new energy levels which are not equivalent with the same energy. See, this is the energy scale. This is the energy scale. This, okay. This is the energy scale. This is the energy of this atom. 1s level of this atom. And this is the same energy of this atom. So 1s energy of A atom and 1s energy of P atom is same. E only, right? But if 1s of B and 1s of A brought close together, the electron position, that is the wave function, electron wave function, the orbitals overlap and it forms two levels, which is bonding as well as anti-bonding. These energy levels are somewhat different from E, right? Okay, like happened here when all these levels and all these levels of P are brought close together, then it will end up with two sub-levels, two levels. This is one level, this is for that valence levels, okay, valence level. For consider this is 1s and this is 2s of A and this is 2p of B. For example, we are taking this is 1s of B, this is 2s of B and this is 2p of B, and if A and B are bring close together, this is A atom, this is B atom and this is AB atom, okay, this is AB atom, this form two levels of 1s and two levels of 2s and two levels of 2p. Now you understood, right? If two atoms bring close together, it forms two levels of two levels. If n number of atoms bring together, okay, then it end up with 1s band, 2s band, 2p band, etc. Okay, so an isolated atom are brought close together, form a solid, the electron wave function overlap, then this is here they are talking about the equilibrium position, right? You cannot able to bring these atom and this atom very close enough, okay, there is some restriction. Up to that level only you can bring together, so there is some equilibrium position, okay. That they only telling there, so there are has some restriction, okay, has some restriction, that is only they are telling in this point. Various interaction occur and at a proper interatomic spacing for the crystal, the forces of attraction and repulsion find a balance, that is at the atoms find its equilibrium position, okay. It does not move very close to the atom or it does not chipper away from the atom. There is some where attraction and repulsion are equally balanced, there the next atom, up to that level only that next atom can exist, okay. Then due to the Pauli's exclusion principle, the discrete energy levels of individual atoms split into bands belonging to the pair instead of individual atom, okay, because one atom one level, if you bring the another atom, two levels form two sub levels, okay. Here you get two electron, here you get two electron, okay, 1s can accommodate 2 electron, here 1s can accommodate 2 electron. Now we are end up with 4 electron. If you bring these two atoms close together, you are ending up 4 electron. But according to Pauli's exclusion principle, okay, one levels can accommodate only 2 electron. That is why two energy levels are formed. Okay, now I think now you understood this third point also. Okay, next, in a solid, due to large number of atoms, the split of energy levels for essentially continuous bands of energy. Okay, so in the solid, large number of atoms are there. So all these levels are combined to form the energy band. Now I understood. Now I think you people are understood what are bands. Bands means group of energy levels which seems to be continuous. How the bands are formed? Because of Pauli's exclusion principle. Okay, bands are available only in the solids, not in the individual atom or a very small group of atom, right? Okay, now we go. The same only I showed here as a pictorial representation. This is the individual atom and this is the energy levels 1s, 2s, 2p, etc. Okay, then this is the group of atoms, how this energy level forms the band. Okay, here they take sodium as the example. This is sodium, 11 electron, atomic number is 11. So 1s, 2s, 2p and 3s. 1s 2 electron, 2s 2 electron, 3p 2p 6 electron, 3s 1 electron. Now this is for one atom. If you combine, if you bring three atoms close together or the three atoms are in equilibrium position, now one is split up into three energy levels of different energy, not seems to be the same energy of 1s, of different energy. Similarly, the 2s orbitals of 3 sodium atom form 3 2s orbital and so on. Okay, now you understood how it forms. If you bring n atoms together, n number of sodium atoms together, it forms a continuous energy levels called band. This is 1s band, this is 2s band, and this is 2p band. Okay, n is the number of electron. See, for one level it occupies 2 electron, right? So that is why for here it is number of n number of levels are there. That is why you put 2 is the number of electron and n is the number of levels. So 2a number of electrons are present in the 1s and so on. Okay, now I think you are understood what I am telling. And this is the energy bands of conductor, semiconductor and insulator. In the conductor, almost all the metals are conductors. In the conductors, this is the valence band. There's a red color band showed the valence band. Large number of electrons are available. And this is the conduction band. That topmost level. So few electrons are available. Okay. There is no forbidden gap between valence band and conduction band. Okay. This is called conductors. If the valence band and conduction band, there is some forbidden energy gap whose gap is less than 3.5 electron volt. Okay, the gap should be the gap. This is the energy gap. Energy gap Eg should be less than 3.5 electron volt. Okay, if the energy level is greater than 3.5, then it is end up with insulator. Okay, here only few electrons are available in the semiconductor because these are the thermal electrons. The electrons are excited from the valence band to conduction band because of the thermal energy available from our surroundings. And this is the insulator energy band diagram of insulator. Here this is the valence band and this is the conduction band. The energy difference between the valence band and the conduction band is almost greater than 3.5 electron volt. So there is no thermal energy. Thermal electron cannot be possible in the conduction band. Okay. If we give large number of potential difference also, the electrons cannot shift over here. That is why it is called insulators. I think I will stop here. I think you people are understood what are bands, energy bands, how energy bands are formed, what is the difference between energy levels and energy bands, and one more thing you should familiar that energy bands are seen only in the solids, not in the cases of individual atom or small group of atom. Okay, thank you.